Hi everyone, welcome to lesson 7.7, Trigonometric Identities. We're going to learn a new way of thinking about our trig identities, or our trig functions, but it's really connected to our old rules here. So let's call this first one secant x. Let's call that identity number 1. It says secant of some angle is the equivalent of 1 over cosine. Now, whenever we see 1 over anything, I'm directing your attention here for just a second. When we see 1 over monkey, for instance, I want you to think of it as the reciprocal of monkey. It's when you flip it. And so that's what's going on here. We're just saying that secant is, we would think of this as the reciprocal of cosine x. And indeed, we know that's true. We can confirm it based on our old rules. If cosine's x over r, secant is r over x, so it truly is the reciprocal. Okay, so that's all that this is saying. Now, please remember how to match these up. I know that the reciprocal of cosine starts with, if cosine starts with a c, then its reciprocal will start with an s. So they're always paired based on the opposite letters. Similarly, sine's reciprocal can't start with an S, it's got to start with the opposite letter, which is a C. Hence, sine's reciprocal is cosecant. And then obviously, tangent and cotangent are partnered. There's no memory trick needed there. Okay, so again, remember, opposite letters are paired. Our second, let's call this formula 2, says that cosecant is the reciprocal of sine. Again, we know because the letters alternate. Now, rule number 3 says that tangent is the equivalent of sine over cosine. This one we may have talked about before, but maybe some of you forgot, so just commit that one to memory. Tangent really is sine over cosine. Let's call this formula number 4. Now we're saying cotangent is cosine over sine. Well, that makes sense. If we know tangent and cotangent are reciprocals, then if tan is sine over cosine, this guy should be the flipped version of that, and indeed it is. Let's call this formula number 5, and then formula 6 is just saying the opposite way around. So these two are very closely related. Cotangent is the reciprocal of tangent. Now, before we move on to our actual problems here, let's do a quick note on fractions. And I'll make this quick because most of us know these already. If I have a over b times b over c, I can simply cancel my common factors on the numerator and denominator and find that the answer is just a over c. So when it comes to multiplying, we can cancel our common factors. On the other hand, in example 2, when I'm dividing fractions, we are going to rewrite that as a over b times, instead of c over d, I'm going to multiply by the reciprocal, so that'll be d over c. So my final answer will be ad over bc. The key takeaway there is we multiply by the reciprocal. Only when we have two fractions and we're dividing them. So we take the bottom and we flip it, turn it into a multiplication problem. And then in this third instance, notice that we're actually adding our fractions. So adding and subtracting are by far the most complicated because we need to find a common denominator first. So I'm trying to look for an LCD. If I have a b and a c, I'll just multiply them together, and bc will be my common denominator. So my answer will be something over bc. Now, I need my first denominator, b, to become bc, so I'll multiply top and bottom by c. And for the second term, I'll multiply top and bottom by b. So now I have bc, cb, they're the same thing. So my final answer will be ac plus b times b, which is b squared. But I was able to now add, these because they now have a common denominator. So that's the key takeaway for adding and subtracting is find a least common denominator when adding or subtracting fractions. Great. So now that we've covered our fraction rules, let's jump in with some problems. It says to simplify each trigonometric expression. So I want to rewrite it in a way that's more simple. Well, tangent, if you remember from identity number 3, tangent is sine x over cosine x multiplied by, there's an invisible multiplication, cosine, well, we don't need to rewrite cosine, I'm just going to leave that as cosine x. Notice that I'm actually multiplying fractions, so I should probably put that cosine over 1. That way I can multiply straight across. But do you see what we can do first? Yeah, my cosines will cancel, leaving me with a final answer of sine x over 1, which just simplifies to sine x. So really, tan x cosine x is just the same as sine x. And I did all that just by using my identities from above. So you might be thinking to yourself, how do I know which formula to use? Because if you notice, 3 wasn't the only formula we could have used for tangent. We could have also used number 5. Let's see what would have happened if we'd used rule number 5.
So if instead of writing sine over cosine for tangent, let's say I wrote 1 over cotangent x. And then I left my cosine as cosine x over 1. Well, immediately I run into a problem because I can't cross these out. There's no way to simplify. I just end up with cosine x over cotangent x when I multiply straight across. But that's not really more simple than what we started with. So I'm going to give you the trick or the key to always simplifying successfully without wasting time.
And here's the steps. Step 1, convert every term to sine and cosine. And that's what I did. I used the formula that involved sine and cosine so that I could avoid wasting time with formulas that weren't going to get me anywhere. Once you're done with step 1, everything else you just simplify by multiplying, dividing, or whatever the question calls for. So pause the video, copy these rules down, and then why don't you try number 2 on your own? Okay, so for number 2, you should have rewritten cotangent as cosine over sine if you're following our rule to rewrite everything in terms of sine and cosine. And since sine is already sine, we don't have to rewrite it. The only thing we did was put it over 1 so we could multiply straight across. Now immediately the sines canceled, leaving us with cosine over 1, which is just cosine. All right, let's jump into number 3. So cosecant. Which rule will we use for cosecant? So some of you have already memorized these, and I'm really proud of you if you already did. And cosecant, you'll remember, is the reciprocal of sine x. I remember because cosecant starts with a C, sine x starts with the opposite letter, so I can immediately write it without even looking at my rules. And then tangent, and remember, we want to make everything in terms of sine and cosine. Well, tangent will be sine x over cosine x. Again, I didn't use this formula because that's not in terms of sine and cosine, that's cotangent. So from there, we have the same situation where we can cancel our common factors, and now we're left with on top a 1 by multiplying straight across, and then a cosine x on the bottom. So we're not exactly done here. 1 over cosine x is one of our formulas. Let's look up. Right here, formula number 1 says that the reciprocal of cosine x is secant, and so we should replace that with secant x because it's a more simplified version. Okay, number 4. Pause the video, try this one on your own. Again, you want to rewrite this in terms of sine and cosine, and you'll want to rewrite this in terms of sine and cosine. Okay, so for number 4, you should have rewritten both expressions. Secant was 1 over cosine, cotangent was cosine over sine. We canceled our cosines because multiplying in the middle allows us to do that. We're left with 1 over sine, and so our final answer was cosecant x. See how you did. If you made a mistake, it's a good time to pause the video and reflect on what went wrong. Let's continue. For number 5, let's begin. I want to rewrite tangent because I can turn it into sine and cosine using formula 3. And I'll also rewrite cotangent, which is cosine x over sine x, which I believe is formula 4. Now notice we have a fraction over fraction. What's the only way that we divide fractions? We'll rewrite it by keeping the top the same and multiplying by the reciprocal of the bottom. So instead of cosine over sine, we have sine x over cosine x. And now we're going to multiply straight across. Notice that we can't cancel because they're not on opposite sides of the fraction. So we're just going to have to multiply sine x times sine x, which is sine squared x. So when we want to show that sine is being squared, we put the square between the trig function and then the variable. So we call this sine squared x. Over cosine times cosine is cosine squared x. Now this is looking very similar to one of my formulas. Sine over cosine is formula 3. Let me highlight that. But notice the difference. In our problem, we have both the numerator and the denominator being squared. So that means that our answer is actually going to be, instead of tangent, it'll be tangent squared x. So this only works if both the numerator and the denominator are squared. Now here's the real mathematical reason why. I can rewrite sine squared over cosine squared like this. Sine x over cosine x squared. Because if I multiplied it by itself, then it would turn into this expression, right? Sine over cosine times itself 2 times. So really, I can replace the inside expression with tangent, and that's why my answer is tangent squared x. Okay, cool. So we've been sticking with our method of always converting to sine and cosine. But this problem really shows the limitations of that method. Let me show you a faster way to do this problem. So if you're familiar with your trig functions, you'll know that tangent and cotangent are already reciprocals of each other. So instead of involving sine and cosine, which by the way is a brilliant strategy 95% of the time. But in this case, if you recognize that tangent and cotangent are already super close, then you can just replace cotangent with 1 over tangent, because cotangent's the reciprocal of tangent. From there, you're recognizing, okay, I need to multiply by the reciprocal. So the top will be tangent x times the reciprocal of the bottom, which will be tangent x over 1. Now we can put our first tangent x over 1 also, so our final answer will be tangent squared x all over 1 times 1 is 1, or just tangent squared x. Wasn't that a lot faster? Yeah, now the point of that wasn't to waste anyone's time, but to show you that in these problems there is a kind of a unique beauty in that you can solve them in multiple ways. So you can often simplify with multiple methods. And so some of you guys will do a problem in one way, some of you will do it in a totally separate way, but at the end of the day, if you're using your formulas correctly, your answers will always match up. Okay, let's give me a break from talking and you try number 6. Pause the video, give it a shot. Okay, so we're back with number 6. So for this problem, I rewrote tangent as sine over cosine. And then I left sine the same since it's already in terms of sine. I put it over a 1 though. That way I can multiply by the reciprocal. So when I flipped it, it became 1 over sine. When I did that, I noticed that my sines could cancel, leaving me with 1 over cosine x which is a formula and is just secant. So let's come back to 7. If we remember that tangent x is sine over cosine, then we know cotangent will be the reciprocal of that. So I'm going to write cosine over sine. Divided by, I'm going to draw that division sign a little bigger, and that's going to be cosine x. Now, we don't want to leave this cosine x at the bottom without a fraction, so let's put him over 1. That way, we see clearly we have a fraction over a fraction, just like in our examples at the beginning of the lesson. So let's multiply by the reciprocal of the bottom, see what happens. I have cosine x over sine x times 1 over cosine x. Ooh, I notice immediately I have a cancellation. So my final answer is 1 over sine x, which, wait a minute, this means the reciprocal of sine. That's one of our formulas. My answer is cosecant. That is the reciprocal of sine. So these problems don't have to take very long. I started off a little bit slow just to do some explaining, but you should be able to race through these with, like I would say, a maximum of 1 to 2 minutes per. Try number 8 yourself. All right, for number 8, we rewrote sine squared x. Actually, we left it as it is. We just put it over a 1. And then cotangent was cosine over sine. Now we notice that these signs canceled, but we were left with 1 on the top. And so our final answer, multiplying the tops across, is sine x times cosine x all over 1, which was just sine x cosine x. Now, you might be thinking, hey, shouldn't we be able to simplify this? But there is no formula. If you notice in the top of your notes, there's no formula for sine times cosine. Whatever way you try to rewrite this, it won't get any simpler than this. So we're good to go. As long as your answer is in terms of sine or cosine, there's no additional work to do. But if my work had been like secant x times cosine x, then I would think, okay, let's rewrite that. And then you would see likely that there is some work you could do. So that just ended up being 1. But in this problem, we are good to go. Okay, so that was numbers 1 through 8. I want to give you a chance to pause for the day. You can continue on to part 2 of the video, which is going to be tomorrow's lesson, or you can just stop here for today, Monday, and relax.